Okay, a ball is dropped from a height of 16 feet and allowed to bounce repeatedly. On the first bounce, it rises to a height of 12 feet, and then on each subsequent bounce, it rises to 75% of its previous height. So it starts off going down 16, and up 12, down 12, up 75% of 12, down 75%, 75%, pretty much all the way across like that. So it's going up by 12. Over here it's, well, whatever 75% of 12 is. 12 times 0.75 gives you 9, so then this one would be 9 feet, and it would just sort of continue along like that. So the ball is dropped. Now they want a geometric sequence. Geometric sequences are usually of this form. A sub n is equal to a sub 1 times the ratio to the n minus 1 power usually. That's where we're going to go with it. So if I want to start this out, a sub n is going to be, or a sub 1, my first term is going to be 12. My ratio is 0.75 because that's how much each bounce is. And then after that I have n minus 1. So let's look at this for a minute, make sure it works. First bounce should be 12. So if I plug in 1 for the first bounce, that makes the 0.75 turn into just 1, so then that's 12. This actually works out really well. There is the geometric sequence that will model the first n bounce heights in feet. Next, what they're looking to do is they want a geometric series to model the total vertical distance the ball travels as a result of a certain number of bounces. They want you to exclude the distance traveled before the first bounce, which was 16 feet. So we're not going to count that initial 16-foot drop. What they want to know is how far up and down is that thing climbing. So remember the difference between a series and a sequence is in a series you are actually adding the terms together to come up with a sum. And we want n bounces. We don't know how many bounces that is, but also if you remember, if you're talking about a sum, you can put this big old sigma in front of it. And we know that we want to go n bounces. We have no idea how many n is. If you recall, the actual formula we had was 12, 0.75, and then we went to the power. Now we can't use n for this because we've already got n that signifies the last term. We have to start with some number that will allow us to plug in number of terms until we get to that n. I'm going to pick I just because I want to. And so this would then be I minus 1. Now here's the thing. They want the total vertical distance the ball travels. Well, it travels up by 12 and down by 12. So it's actually going 2 times as far each bounce, vertically speaking. So I will just multiply by 2 out in front of the whole thing. Next, we want to know how far does it go vertically as a result of the first 3 bounces. So we're going to look at that same little formula that we had before, except that instead of n, we're going to have 3. And again, a sub 1 is 12. The ratio is 0.75. And there we are. Now, they actually want you to do this 2 different ways. They want you to find the first 3 terms and add them together. And then they also want you to use a formula, because there's a nice quick little formula that'll do this fast. So if I'm going to do the first 3 terms, let me see if I can change my pen. I suppose I can't. Okay, so if I'm going to do the first 3 terms, I want to think of if I plug in a 1 here for the I, if I is 1, then 12 is the first term. If I equals 2, then we already discovered that 9 was the next one. And if I equals 3, that's 12 times 0.75 squared. That yields 6.75. So we have all of these added up together. So 12 plus 9 plus 6.75 is 2775. But remember, we're bouncing, so you're going up and then down, up and then down, up and then down. So you actually have to do 2 times 27.75, and that's the 2 from right over here. And what you get with that is 55.5 feet. That's how far it goes. Now there's actually a nice little formula that will also bring this to you much more quickly, which is very, very nice. Formula works like this. You take a sub 1 and then you multiply it by, well, a fraction. And on the top, 1 minus the rate to the n power. And on the bottom of that fraction, 1 minus the rate. So we have that. Now when I put that in the calculator and I work it out, I wind up with 27.75, but again, we've got two bounces, so 2 times 27.75 equals, well, wow, 55.5 feet. Lovely. Finally, they want to know after the first 9 bounces. So and again, we're not doing that initial drop of 16. We're just looking for the first 9 bounces. How far has it traveled? Well, we can, again, think of it this way. Think of that nice little formula we had before and said now n isn't 3, it's 9. And we just do all of this. I minus 1, my bad. And again, you can use the formula. Remember, the formula always starts out with a sub 1, and then in the numerator we have 1 minus the rate to the n power, and in this time is 9. And in the denominator, 1 minus 0.75 because that's my rate. I'll do that. Oh, but remember, I got to multiply it by 2. Got to multiply that by 2 because remember, again, with the bouncing, we've got the up and we got the down. So that winds up being, well, approximately 88.8 feet altogether. Let's make that an approximate little symbol there. And those are the answers. Thank you very much.